Hey guys, how you doing? If you clicked on this video, you probably are wondering, well, why the hell is the derivative of a constant equal 0? You might have heard that a lot. Oh no, the derivative of a constant is just gonna be 0, so you totally forget about it. But don't take things just for granted always, okay? If they say something, yes, but there is a reason behind that. If you can understand the reason, well, you're gonna get very good at understanding things deep to their roots, okay? So that is basically what I'm here to do today. I'm gonna show you why, using the definition of a derivative, why the derivative of a constant is equal to 0, okay? So let's do it. So, to begin with, let's say that we have a function f of x, and we're gonna say this function is just simply 10, okay? It has no input. That means that, for example, if we've got a graph like this, and we know this is going to be f of x, and if f of x is always constant, so if f of x is always a line in the y values, this would be like, this is also y. This is basically a line that goes here, okay? And this is equal to 10, basically. This is the function, okay? And this is basically what you've got when you have a function that is constant. Now, what is the derivative of this? Well, we could use, first of all, remember that a derivative is basically taking a slope, okay? So you could say, what is the slope of this, for example? Well, we know we can compute slope saying that this is gonna be the change in y divided the change in x. Okay, now let's actually do it. So we're gonna take 2 points. So let's say this is 1. Let me write it. So, well, we see it 1 and 2. Those are gonna be our x values. So let's say that this is going to be, we know the change in y. Is there any change in y, first of all? Absolutely not, because y is always gonna be 10, okay? So you could say that this is just going to be 10 minus 10. There is no change in y. We are staying at the same position. Change in x, how much is it? It's just going to be 2 minus 1. This is just going to be 0 over 1. How much is this? Clearly, it's going to be 0. That is, first of all, we're saying that the slope of a line that is constant and that is horizontal, so y equals something, is going to be equal to 0, okay? Now, in terms of a derivative, what does that mean? Now, well, something we could do is the following. We could say, use the definition, for example. Now, how do you use the definition here if you don't even have inputs? Something we could try, and it would actually be the first time that I try it in a more rigorous way. You can say that this is just simply 10 to the x to the 0th power, okay? So let's see how much we get if we do that. So f prime would be equal to, we should get 0, okay? You're gonna see, we should get 0 if we do that. So let's see it. The limit as h approaches 0 in the expression, 10, and actually no, well, we don't need these parentheses right now. We just have 10 times x to the 0th power. This is gonna be weird. No, actually no, it would be x plus h to the 0th power minus, yeah, it makes sense, minus 10. And all of this divided by h. And now, well, what do we get in here? We know everything to the 0th power is just going to be 1. So in this case, we're going to get 10 minus 10 divided by h. Now this limit, it might look kind of weird, but well, it'll actually, I mean, you cannot really compute it analytically, because right here you would just simply get 0 over h. And now you have the limit as h approaches 0 in the expression 0 over h, which, well, you cannot substitute in 0 because, well, it doesn't work. But you can suppose that any number, let's say this is going to be 0.000, just a lot of zeros, yeah, whatever, 1. This is a number that is not 0 just yet. And if we divide, if we try to plug that into 0, we know that is the same thing as if we divide it 0 by 10 or 0 by any number that is way larger than this. So this is just simply going to be 0, okay? And that makes a lot of sense because that is exactly what we got up there, okay? Now this proves why, if you have a constant line, the derivative of that line is just going to be 0 because there is no slope. Remember that a derivative is a slope. And we're trying to see in an instant, in an infinitely small instant, how steep is that slope. If we do not even have a slope, well, that's just going to be 0, okay? This is the reason why the derivative of any constant is 0. So I hope you guys enjoyed this video and see you in the following one.